Okay, what we're going to do in this lecture, we're going to combine two functions. Okay, so we're going to add, subtract, multiply, and divide two functions. So before we actually start on the notes that I've prepared, there are two ways you could do this. Let's say that I had a function f of x, and I had a function g of x, and you don't have to take notes on this necessarily. And what I wanted to do is I want to put a value of x in for 2, and I wanted to see what they equal if I add those two together. So what I'd do is, let's say I want to evaluate those for x equal to 2. Notice they both have the same variable. So what I would do is I would put 2 in to the f equation for x, and then I would put 2 in to the g equation for x, and then whatever this is, this may be 10. The g of x may be 15. When I put 2 in it, I get 25. Okay, but there's another way we could do this. For both addition, subtraction, multiplication, and division, we could combine the functions together first before we ever substitute the 2 in, and we could create a new function. Let's say I have a function that I want to create x, h of x, and what I'm going to do is I'm going to add the functions f and g together first, all with x as their variable, creating a new function h, and then I could substitute x equal to 2 in for the x in my new equation. So we're going to combine the equations first, then we'll substitute the variable in. All right, so it's like if I was going to add two equations with x, let's say that f of x would be equal to, say, x squared, and let's say g of x would be equal to x. Well, then when I combine those, I could say h of x, the new one, would be equal to x squared plus x. I'd simply add those two together. Okay? So, and I'm going to go down and show you how that works real quick. And we're going to, the actual operations aren't too hard, but figuring out the domain can get a little tricky. And we'll talk about that in a second. So here's just a couple quick examples. This is in the book. So what this is showing is that I'm having a new function, f plus g. And notice that they're in parentheses saying that I'm adding the f and g together with the variable x. So an example would be if f of x is equal to 5x and g of x is equal to x plus 2, that when I add those together, that would be 5x plus x plus 2. So that would be 6x plus 2. And notice that I still have the variable x. So that would be my new function that I get when I add those two together. Same thing as if I had subtraction. Now you have to be careful, because if this was f of x right here and I'm subtracting g of x, you subtract the whole g of x. That means this negative must distribute to the x, right? So that would be 5x minus 2 as this subtraction distributes to the minus. And so that would be 4x minus 2. So you can see how it works through the multiplication and the division. So the operations are pretty straightforward. But here's where we may have a little issue. Let's talk about the domain and range. Actually, let's just talk about the domain. And what the domain is, those are the values that I'm allowed to put in the equation. So what could I put in? Okay, so one of the things that we need to have when we're concerned about the domain is what values of x can we use and put in the equations. And the two things that we're really going to give us problems if we're taking the square root of a negative number. So let's say, for example, that I had some function f of x that would be equal to the square root of x. Then the domain of that is going to be x has to be greater than or equal to 0, because I can't put a negative number in there. The other thing I'm going to have to worry about is if I'm happen to be dividing two functions. Let's say I'm dividing, say, x all over x plus 1. Well, I can't have 0 in the denominator either, so you can see that I'm not going to be allowed to put to have this whole denominator be 0, so x would not be able to be equal to a -1 because that would give me 0 as a denominator. So we're going to have to work with those limitations and come up with some domains. And this is how it works. So if I have a function, and whether I'm adding, subtracting, multiplying, or dividing, my domain of the function is going to be the and of the two domains. The most restrictive are the combinations, so it'd be the and. So for example, if I would have a domain of x is equal to all real numbers, and let's say I had a domain of x is greater than or equal to 0, and I had a domain where x has to be greater than 0, if I had those three domains, if you look at the overlap of all of those, that would have to be the domain. This would be the domain, right? So what we're really looking for is the intersections of all the domains. So let's try another situation there, see what we can come up with. So if I would have this as my other domain, where x is not equal to 0, let's think of that as, okay, here is the domain of x is equal to all reals. That's the whole number line. But then I add the domain in there of x greater than or equal to 0. That would be this number line. And then I would have the situation where x could not be equal to 0. So x could be everything but 0. And if I would look at the intersection of all three of those, what my end value would be x would have to be greater than 0. So that would be the intersection of all the domains, the overlap. Okay, so here's where we're going to get into some problems, is particularly when we're dividing. Okay, so if I had, let's say f of x is equal to the square root of x, let's say g of x is equal to x. And if I wanted to add f plus g of x, the domains for that, let's think about the domains. So the domain of f of x, okay, that's going to be equal to, because it's got a square root, x is greater than or equal to 0. The domain of g of x, which is simply x, is all real numbers. So the overlap of those domains, which is what the domain of f plus g would be, the overlap of all real numbers and x greater than or equal to 0 would simply be x greater than or equal to 0. That would be the domain of my added function. Okay, let's think about if we would have the function f all over g. So f divided by g of x. F has the same domain, right? There's f. There's the domain of g. But now we have the added situation occurring where if I would put those together, I would have the square root of x all over g, which is x. And notice that when they are in their division form like this, that x can't be equal to 0 either, because I can't put a 0 in there. So x cannot be equal to 0. So the domain of f divided by g of x would not only be what we had before, where x is greater than or equal to 0, but x couldn't be equal to 0 either, because that makes my denominator equal to 0. So that domain would be simply x greater than 0. Okay, I got interrupted there, so I'm not really sure where we're at. So let's kind of summarize about this domain thing. Okay, so for the domain, they're going to be the x values that work in both functions. It's going to be the intersection or the overlap. Now, for division, we're going to have the extra case that we cannot have a denominator equal to 0, so we're going to have to look for x values that make the denominator go to 0 and exclude them from the domain also. Okay, the other thing that we have to be aware of also, and I think I already mentioned it, was that the domain cannot include x values that produce negative square roots or negative fourth roots. Okay, so let's go down and work a couple examples. So the first example that we have is it's an addition one. It says, so we're going to take the function f and function g, we're going to add those together, and we're going to state the domain and evaluate it when x equals to 4. So let's go ahead and find the domain for f. So the domain of f of x, we can see that f of x is equal to 3 times the square root of x. So the domain of f of x is going to be x is greater than or equal to 0 because you can't have any negative square roots. We see that g of x also has a square root there. So the domain of g of x is also going to be x is greater than or equal to 0. And let's go ahead and take g of x and f of x and add them together. So f plus g of x, it's going to be f of x plus g of x, which is going to be equal to a negative 7 times the square root of x. And the domain of f plus g of x is going to be the intersection of the two domains of f and g, and that's going to also be x greater than or equal to 0. The last part says let's evaluate it for when x is equal to 4. So let's go ahead and put 4 into this. So that would be, we will write that f plus g evaluated at 4. So that would be a negative 7 times the square root of 4. The negative 7 times 2 would be equal to negative 14. Let's go to a subtraction problem. Okay, so let's take a look at the domain of f. And we can see that f is equal to 3x squared minus 2x squared plus 5. There are no square roots or even roots, and there's nothing as a denominator, so x is going to be equal to all real numbers. Let's take a look at the domain of g of x. And g is similar to f. It doesn't have any roots in it at all, and it's not a denominator, so x is going to be equal to all real numbers. So let's actually do the subtraction. So we're going to have f minus g of x, so that would be 3x squared minus 2x squared plus 5 minus the entire g of x. Okay, let's go ahead and distribute the minus sign. So that's 3x squared minus 2x squared plus 5, then minus x cubed. Then I have a minus the subtraction times this distributed to the negative 3x squared would be plus 3x squared. The subtraction distributed to the 4x is minus 4x, and the subtraction distributed to minus 2 would be plus 2. Combining like terms, I'm going to get, actually there must be something wrong with this one. Let me change this. This was a cube. Which is going to make this be a cubic and this be a cubic. So I wrote the problem wrong at the start. So let's go ahead and change that. Okay, so now combining it, I'm going to have 3x cubed minus x cubed. That's 2x cubed. Moving on to my squares, I have a negative 2x squared plus 3x squared. That's plus x squared. Then I have my x terms. I only have an x term over here, minus 4x. Then I have plus 5 and a plus 2 would be plus 7. So that would be f minus g of x. The domain for that is going to be the intersection of the domain of f and the domain of g. So the domain of f minus g of x is going to be x is equal to all reals. And the last thing I have to do is substitute in a value of a -2. So I'm going to write that f minus g, evaluated at a -2 for x, would be equal to 2 times a -2 cubed, plus a -2 squared, minus 4 times a -2 plus 7. A -2 cubed, that would be 2 times a -8. Over here I have a -2 squared, that'd be 4. And I have a -4 and a -2, that would be plus 8, plus 7. So 2 times a -8, that's a -16. Plus 4, plus 8, plus 7. So -16 plus 4 is a -12. -12 plus 8 is a -12 plus 8, that's a -4 plus 7. So it evaluates to 3. Let's go to multiplication. Okay, so let's take a look and find the domain of f of x equals to x squared. So the domain of f of x would be equal to the domain of something squared. That's just simply going to be x is equal to all real numbers. Now the domain of g of x is a square root, so the domain of g of x is going to be x has to be greater than or equal to 0 because I can't have a negative under the square root. And let's go ahead and multiply those out. So if I have f times g of x, that's going to be equal to x squared times the square root of x. The domain of that is going to be the intersection of the domain of f and the domain of g. Which is going to be the intersection of those two would be x has to be greater than or equal to 0. It's the overlap. And then the last thing I do is I have to put 9 into this equation. So f times g evaluated at 9 would be equal to 9 squared times the square root of 9. That would be equal to 81, and the square root of 9 is 3, so that would be equal to 243. Okay, let's move to a division example. So let's look at the domain of f of x. F of x is equal to 6x. So the domain of that is equal to x is equal to all real numbers. The domain of g of x, okay, g of x is equal to x to the 3/4 power. So I'm taking the 4th root. That's an even root, so I cannot have a negative number. So that would be x is greater than or equal to 0. And let's go ahead and set the problem up. So I've got f divided by g of x. That's going to be 6x all over x to the 3/4. Okay, so now what I've done is I have an x in the denominator. So I can't have that x. The denominator can't be equal to 0. So when I do the intersection of these two domains, I'm also going to have to add the domain to that x can't be equal to 0 either because g of x is now in the denominator. So if I take a look at the fact that x could be equal to all reals, x has to be greater than or equal to 0, but x can't be equal to 0, the domain of f divided by g of x would be x greater than or equal to 0. Now let's go ahead and evaluate this for 16. So putting 16 in for x, I'm going to get 6 times 16 all over 16 to the 3/4 power. So if I take the 4th root of 16, that's going to be equal to 2. So that's 6 times 16 all over 2 cubed. That'd be 6 times 16 all over 8. 8 divides into 16 twice. So my answer would be 12.